Good morning. In this today's video lecture series, we will discuss about one of the type of casting, centrifugal casting. Already we have discussed about the shell casting and what are the steps we will follow during shell casting, and also we have discussed about the investment casting and the steps followed by it. Now we will discuss about centrifugal casting. Centrifugal casting is the casting process used to produce cylindrical parts with a high level of accuracy, density and strength. It is particularly well suited for making components such as pipes, cylinders and rings. The process involves pouring molten metal into the spinning mold using centrifugal force to distribute the metal and form the desired shape. Here, the centrifugal force plays a major role in it. Steps in centrifugal casting are mold creation, and then molten metal pouring, metal distribution around the mold, and then solidification, cooling and extraction, and then the final process is the finishing. This is the image, 2D image of a centrifugal casting. This is the mold. Here the molten metal gets poured into the spinning mold. Here the mold, it can be placed either in the horizontal direction or else in the vertical direction, and with the help of the motor the mold gets spindled, and due to the centrifugal force the molten metal gets distributed into the inner layer of the mold cavity. Here we will explain in detail. Mold preparation. First step is the mold preparation. A cylindrical mold typically made of either metal or graphite is prepared and positioned either in the horizontal direction or else in the vertical direction. The mold can be coated with the refractory material to prevent the molten metal from sticking to it and also to improve the surface finish. Second step is the molten metal pouring. The mold is rotated at high speed centrifugally. The molten metal is poured into the spinning mold. Due to the centrifugal force generated by the rotation, it causes the molten metal to be pushed outward against the mold walls. Next, metal distribution. The centrifugal force ensures that the metal is evenly distributed around the mold's circumferences, forming a uniform, dense and defect-free casting. Any impurities or less dense materials tend to be forced towards the center and can be easily removed afterwards. And then is the solidification. As the molten metal cools, it solidifies against the mold walls, forming the desired shape. The speed of the rotation, mold temperature and pouring temperature are carefully controlled to ensure proper solidification and minimize the defects. Next step is the cooling and extraction of the cast part. Once the metal has fully solidified, the mold is stopped and the casting is allowed to cool further. The casting is then removed from the mold cavity. The final step is the finishing process. After the casting is removed, any excess material such as the inner surface layer that may contain impurities is cut off. Additional finishing process like polishing or heat treatment may be applied to achieve the desired final properties. These are all the steps carried out using the centrifugal casting. First one is the mold preparation, and then the pouring of molten metal into the spinning mold, and due to the centrifugal force the metal gets evenly distributed around the mold, and then the solidification process takes place, and then cooling and extraction process, and finally is the finishing process. There are about majorly three different types of centrifugal casting. One is the true centrifugal casting, semi-centrifugal casting, and then centrifuging. It is used for producing hollow cylindrical particles like pipes, tubes and rings. The mold rotates horizontally and the centrifugal force creates a uniform wall thickness. It is a true centrifugal casting. Next one is the semi-centrifugal casting. It is mainly used for solid parts that are symmetrical such as wheels and pulleys, etc. The mold rotates vertical direction and the centrifugal force helps in achieving better material distribution and density. And the final one is the centrifuging, a variation of centrifugal casting where multiple molds are attached to the center spool. The assembly is rotated and the molten metal is distributed into the molds using centrifugal force. This method is typically used for casting smaller parts. Advantages are high material density can be produced with the help of centrifugal casting, and then we can improve mechanical properties such as strength and resistance to wear and corrosion resistance, etc. And then cost effective for large production runs and the reduced material waste. Applications: different types of materials such as pipes and tubes can be produced with the help of the centrifugal casting. And then rotating machinery components such as turbines, engine blades, engines, pumps can also be produced with the help of centrifugal casting. And then structural parts such as automotive parts, aerospace industry parts can also be produced. And high pressure vessels like gas cylinders, pressure vessels can also be produced with the help of the centrifugal casting. Thank you.